Hi, everyone. Can you hear me? Good. OK, perfect. So I think it's time, and we should start this presentation. So first of all, thank you so much for joining me today. I really hope you're having a great start to this conference. I know it's the first day. And today, actually, I'm very excited to share something that brings together two of my favorite things. First is gaming. So I am from gaming domain, and I've worked in gaming domain for last 7 years. And the second is applied generative AI. This is one domain where most of us are quite curious nowadays. So the title of my session is GenAI Game Coach, Real-Time Gameplay Feedback. And the big idea behind it is actually very simple. So in this talk, we'll explore an imagination where you have your gameplay clips, and we are imagining if your gameplay clips could talk back to you and tell you exactly how to improve if you like gaming, if you're into video games. But the other aspect of this talk is we are not going to talk about SDKs. We are not going to talk about some game engine plugins. We are actually going to take a raw gameplay video, and we'll use AWS-powered offerings to see how we can build an intelligent agent that will guide us and act like a coach looking over our shoulders when we are playing a game online. So before I get into this talk, I'll give a brief introduction about myself. My name is Gagan Jot, and everyone calls me Gagan, so I go by Gagan. I am currently working for Sony Interactive Entertainment, which is basically the gaming division of Sony, known for PlayStation. I have been with PlayStation for almost 7 years now, and I work as a staff software engineer. My focus is back-end engineering, and I've worked in different domains, started from personalization and then jumped into cloud streaming, and my most recent is AI enablement space. So I'm actually very passionate about experimenting with Gen AI for gameplay, for developer tools, for interactive intelligence. And this talk is one of those experiments which turned into a super fun prototype. So we have a limited time, but I'll try to go over a couple of things in this next couple of minutes. So on a high level, we'll talk about what is this skill improvement demand in the gaming industry, why are players struggling. Then we'll look into how generative AI can help players make sense of fast or chaotic combat. And then finally, I'll show you an AWS-powered architecture where we are going to look into different offerings, but mainly focusing on Amazon Bedrock and Agent Core, which basically orchestrates the entire coaching workflow. And I'll also show you a demo video of what I built, what it looks like, what does the coach built using AWS say about a sample clip that I'll show to you. And finally, I'll wrap it up. But if you're interested to continue this discussion, if you have more ideas, definitely let's catch up once this talk is done. Please meet me afterwards, and I would be very happy to take your questions and your further ideas in this area. So let's get started. I think the very first thing is I would basically like to talk about a scenario where you're imagining that you're playing Spider-Man. Spider-Man is one of my favorite games. And you're swinging through Manhattan, chasing a group of thugs. And one brute suddenly charges at you. A sniper laser lines up from a rooftop, and you get hit. In that moment, what you think is, I reacted on time, and I did all the right things, but I still got hit. But if you think about a game which is a Spider-Man-style combat, it's a very fast and chaotic combat. Human reaction time is usually 250 milliseconds, but these telegraphed attacks resolve in 100 to 150 milliseconds. So this mismatch of timing means most of the players cannot even see their own mistakes. So the scope of improvement is very less because you don't even know what you did wrong, what was the move which caused you this kind of hit. And this is not just Spider-Man. This can be actually imagined about most of the games in the gaming world. So looking at some studies, I've seen like most of the players actually misdiagnose their own mistakes in a video game. And that's where we have some challenges, we have some opportunities, and we have a potential solution. So talking about the challenge, like I said, gameplay is chaotic, players don't know what went wrong, and a mistimed dodge happens in 150 milliseconds. A wrong rotation decision happens in half a second. So there is a complete mismatch of time between the player's response versus how the game is responding. And raw gameplay is actually very noisy. Most skill mistakes happen far too fast for players to even break down on their own. So that's where we have the opportunity. We have millions of players who want to get better. They don't have coaches, and they don't want to invest their money into these expensive tools or expensive softwares, which could be also complex to understand. Even studios don't want to invest in huge GPU clusters to build some scalable analysis. So that's where we are going to imagine about a solution, because this is where GenAI can shine. So what if your gameplay could talk back? And what if you had a personal AI coach that understands timing, movement, and decisions just from a short clip? So that's where we are headed. But before we get into the actual stuff that I built, I wanted to show you a sample gameplay clip. It's a long clip, so I'm not going to show the entire clip, but it's relevant because this is the clip which I used for actually performing my demo, or actually building the website and analyzing this clip. This is a game clip which is 578 MB in size, and the duration is roughly 5 minutes. But there is like a lot of action, a lot of movement happening in this clip, and a lot of things happening. So I'm going to play it for a few minutes to show you what this clip is all about. And afterwards, in the demo, you will see like what the coach that I built using AWS had to say about this clip and what could be improved by this player. Anyways, I'll go on to the next slide, because I just wanted to give you a glimpse of this video that I used for my analysis. So now comes the AI-powered architectural solution. So before we jump into the demo, I just wanted to show you a high-level flow of what my architecture looks like. So let's just start at the very beginning. We have a user interface. User interface is basically where the user will input a clip. So you need an interface where you captured a clip, maybe 5 minutes, 10 minutes, whatever long clip, and you want to upload it. So this is an interface. It's a simple React-based single-page application, which is delivered globally using Amazon CloudFront. So that's the CDN layer, which will ensure low-latency access for players anywhere. And not only you will upload the clip, you can also actually see the analysis report on this UI. Also, it has another functionality where you can trigger an actual conversational agent which can talk to you and give you suggestions on the areas that you need suggestions for. So from the next layer, we go on to the API layer. So this clip actually goes into S3 storage. So when you click upload button, it will basically, behind the scenes, we have two kinds of gateways. We have API gateway or Lambda URL function, which will perform different functions. So API gateway actually provides you different endpoints, like there is an endpoint to get the upload URL of your S3 bucket where this clip is getting uploaded. There is an analyze URL, analyze endpoint, which can basically trigger the analysis by AI. And there is also a chat endpoint, which will trigger your chat when you want to chat with the AI agent. On the other hand, I also have Lambda URL function. The purpose of this is actually for bigger size videos. I was actually hitting timeouts on API gateway. So the default timeout is 30 seconds. But for Lambda, you can actually increase this timeout. So for bigger videos, it's better to actually use Lambda instead of using API gateway to upload a video, get the URL, and send it for the analysis. So this is what the API layer looks like on a high level. Next comes the compute layer. So compute layer is basically the different lambdas which this application is using. On a high level, there are 3 different types of lambdas. So there is analysis lambda, which basically is used for generating the S3 pre-signed URLs for video upload, and then it will process your video from S3. Next is the chat handler lambda, which basically receives the chat messages from the front end. It invokes Bedrock agent behind the scenes, and then it gives you the results on the front end. And last is the agent action lambda, which basically is used for executing Bedrock agent action group functions. And this use case that I built, I've used it for just for myself. But even if you want to have multiple users hitting your website, the Lambda is scalable. There will be multiple instances of Lambda coming up if you have multiple users trying to upload video on this website. The storage is S3. And the final is the AI ML layer. So there are a bunch of things here in this layer. We see there is Amazon Bedrock. So there are 2 kinds of ways in which I was basically using Bedrock. So first is I just give my direct video to one of the models that I selected on Bedrock. Bedrock gives you access to a variety of different LLM models. So I used Amazon Nova Pro, which can directly take a video, and it can analyze your video and understand what is happening in this video. The other area which I built in this application is using Agent Core, which gives you a facility to build a production-grade agentic platform. So it takes care of the memory, it takes care of any kind of networking that you want to build. But essentially, I used it to build an interactive coaching chat. So there will be a 2-way communication, you can ask questions, and your chat is also getting stored. So it also retains the history of what you talked. The other parallel analysis that happens behind the scenes is using Amazon Recognition, which is for computer vision. So this analysis helps us to identify what are the different objects in a given clip. What the scene could be about, what is the text. If your video has speech, like you are saying certain things while playing the game and you captured that video, you can actually have a speech-to-text transcription using Amazon Transcribe, which is another parallel analysis that gets triggered. And the last one is Amazon Comprehend, which basically does the sentiment analysis of the entire clip. So this is what, on high level, what the different components look like. I also wanted to quickly show you the prompts which I used for this. So prompts are very important. Behind the scenes, you can have different personas for your agent. This agent is a coach. What kind of coach you want? Do you want a supportive coach? You want a coach that is motivating and saying friendly things, or you want a coach which is very competitive and really giving or grilling a player? That will very highly depend on the prompt. So the kind of language generated in terms of the suggestions from your coach would actually be dependent on the kind of prompts you give. So as an example, I've given, you're an expert gaming coach with years of experience helping players improve their skills. You have access to the player's gameplay, blah, blah, blah. But I've also told it, be conversational, friendly, and motivating. You are here to help them level up their game. So this is like the detailed prompts I gave for different personas. Moving on, I wanted to actually show you a quick video, if it plays. But yeah, this is a demo of the video, which basically takes this same video that I showed you earlier. And as soon as I click the Start AI Analysis, it basically runs behind the scenes. It's uploading your video to S3. The Lambda will trigger all kinds of AI analysis on your video, and it will basically generate you the report of what are the suggestions provided. So what I noticed, like one of the challenges I noticed was it takes a very long time to upload it to S3. And that's where it's kind of taking most of the time. But I wanted to actually forward it and show you the actual prompts or the actual results which came from this analysis. So you can see there is computer vision analysis, which comes from recognition, which shows there's a person, there's a road, there's weapon, there's gun. This is the AI gameplay analysis, which comes from the Nova Pro model. So there's a lot of analysis, but it basically recognizes this video shows a player navigating various environments in Destiny 2, engaging in combat with enemies. And then if you see player performance, that's where it tells there are moments where the player could improve in terms of situational awareness and enemy engagement. But at the same time, if you see the tone, it's very friendly and it's very motivating. The player's gameplay is commendable, especially in terms of aiming and cover usage. So this is a high-level AI analysis, and then there is overall assessment, there is sentiment analysis, and also wanted to quickly show you the coach. So in the end, there is also a button where you can actually trigger this coach. So there are also some custom prompts for this coach. So you can select one of those prompts, or you can actually frame your own question. But if you select one of those prompts, it will basically generate the question on its own. So for example, if you select analyze my performance, it will basically create the question that, hey, can you give me a detailed breakdown of how my performance was? So this is the screenshot of the demos that I actually wanted to show in the video, but it's not forwarding. So I just showed you in the screenshots. So I think the next, I just wanted to quickly touch on the cost side. For my use case, I used all these different offerings, and the total cost for this one video, which is 5 minutes long, was $0.9. Of course, once you build something at a production level, you have to take into consideration how many concurrent users are in your environment, how frequently you want to do this analysis, and how big would be the video size that you're dealing with. So yeah, for a casual gamer, if I have 5 videos per month, it will be $50 per year, or for 20 videos per month, it would be $235 per year, roughly. Latency analysis, the latency, like I said, it did take a lot of time to upload. It almost takes like 8 minutes to upload. So this is one area where I would like to improve it further. The AI analysis is still pretty good. It takes almost like 2 minutes to finish the entire parallel analysis. So the total time is roughly 10 minutes for this 5-minute long video for this entire analysis with the report that you get. I think lessons learned, I kind of already touched on a few of those things, hitting the limits of the size of the video and then figuring out what is the other way for me to pass on these videos to models like Nova. So for Nova, the limit that you get is 1 GB. And if you're uploading it on S3, you can actually upload a video as big as 1 GB. And the other thing I wanted to point out was I did not have to do any kind of frame extraction. Nova recognition, as long as you have uploaded them on S3, they are taking care of extracting the frames on its own. As far as I understand, Nova is basically doing intelligent sampling behind the scenes. So that was all taken care of. What's next? So basically, like I said, I would like to work on the latency aspect, would like to reduce it from 10 minutes to at least make it near real time. I would also like to explore video compression and caching technologies to improve the overall latency and cost. The other area where this would be very useful is for the live streaming platforms, because there is a lot of players who actually stream their videos on platforms like Twitch or YouTube. Can we analyze it, and can we build this conversational thing as and when the players are playing? So those are the areas where I want to explore these things in future. But with that, I would like to share some of the links. So there is a GitHub repo where I have put this entire code with instructions on how to run it. You can connect with me on LinkedIn if you want to continue this discussion even after this conference. But yeah, that is all from my side. And thank you so much for coming to this session. And I see that I'm right on time. But if you have any questions, please meet me afterwards, and I'm more than happy to chat with you all. And with that, thank you so much. Have a great rest of your day.